Right, in this video, we are continuing to talk about reducing expressions, and we have one last question to try. It says, for the functions a of x, which is log base 6 of x cubed minus 9x squared plus 26x minus 24, and b of x, which is log base 6 of x squared minus 4x, determine a reduced expression for a take away b of x. So, I'm going to start with a take away b of x. That means a of x take away b of x. X is the argument for both of them. Okay, I am going to replace a of x with the expression and b of x with its expression. So a of x is log base 6 of x cubed minus 9x squared plus 26x minus 24. And we are subtracting. Now that is one term, so it doesn't need an extra bracket around it. We're subtracting log base 6 of x squared minus 4x. Also, one term does not need to go in a separate bracket. Okay, so I have two logs being subtracted. I do notice that they have the same base, so that's good. If I consult our log rules, we do have a rule here that says if you have two logs with the same base that are being subtracted, we can take them and merge them into one single log by dividing our arguments. So I can take these and merge them into one single log by dividing their arguments. So the first log goes on top. So I'm going to have x cubed minus 9x squared plus 26x minus 24 on the top. And then x squared minus 4x on the bottom. Okay, so we have already simplified the expression by managing to find a way to write it as one single log. However, we haven't actually reduced. In order to reduce, I would need to see if there's anything that divides into both the top and the bottom. And in order to do that, I would first need to factor. So I could try to factor it in here. I think I might try to factor it off to the side and then see how that goes. So I'm going to start with the numerator, which is x cubed minus 9x squared plus 26x minus 24. And I'm going to come over here where I've got some space and see if we can factor that. Okay, so I have x cubed minus 9x squared plus 26x minus 24. So this has four terms. First thing I would look for is a common factor. They do not all have an x, unfortunately, and then this only has a 1 in it, so there isn't anything that divides into all of them other than 1. From there, I would look to see, can I group? It is always worth trying to group to see if that would work. If I did group, I noticed the first two, I could take out an x squared, and I would get x minus 9. So the question is, would I also get an x minus 9 from the other one? Which I don't think I would. So if I took out x squared, I would get x minus 9. And then 26 and 24 only have a 2 in common, so I would get 13x minus 12. The brackets here do not match, which means I cannot keep going, so this is not the method that we're going to use. What does that leave me with? Factor theorem. I'm sorry if I don't sound excited about that. What we need to do is find a factor, and to help us do that, we try to find a list of possible factors by looking at all the things that divide into the last term and divide them by all of the things that go into the first term. So 24 actually has a lot of things that divide into it. So I could do 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 does not go into 24 evenly, and then 6 is already on the list, so I know I can stop. They could be positive or negative. And then on the bottom, it's kind of nice. This is just a secret 1, so the only thing that goes into 1 is 1 times 1. All right, that means my list of possible factors, I divide all of the numbers in the numerator by all of the numbers in the denominator. Since we're only dividing by a 1, that means my numbers are 1, 24, 2, 12, 3, 8, 4, and 6. You know what? I feel like writing them in order today. I don't usually, but I don't have a lot of fractions to deal with. So I'm just going to write them in order. There we go. So what we need to do is find ourselves a number that when I sub it in gives me a 0 as the remainder, right? So we're using a combination of remainder theorem and factor theorem. Remainder theorem is how I am calculating the remainder by subbing the number in, and then factor theorem is that I know that if the remainder is 0, it's a factor. Looking at these numbers, I don't think 1 is going to work, so I might start with 2 and see how that goes. So I'm going to go 2 to the power of 3, and then minus 9 times 2 to the power of 2, plus 26 times 2, minus 24. Oh, it worked. Okay, so my remainder when I tried 2 was 0. Now I said I didn't think 1 was going to work. I normally look at the coefficients, right? So I've got 24, 26, 9, and 1. So if I'm subbing a 1 in, it's really just the coefficients that would make a 0. And I don't think that, like, 26 take away 24 is 2, and then I can't get a 2 out of those, right? So that's why I didn't bother checking that number. All right, if the remainder worked when I subbed in a 2, that means x equals 2. So the actual factor, I would bring that 2 back over to the other side by subtracting to get x minus 2. So that means one of the brackets is an x minus 2. To get the rest, I am going to do some long division and see how many times does x minus 2 go into x cubed minus 9x squared plus 26x minus 24. Oops, I'm going to slide that back over. You don't need to see the calculator anymore. Okay, so to turn an x into an x cubed, I would multiply by x squared. So x squared times x is x cubed, and then x squared times negative 2 is negative 2x squared. And then I would subtract to see what's left over. X cubed take away x cubed is 0. Negative 9 take away negative 2 is actually negative 9 plus 2, so that's going to be negative 7x squared. 26 take away nothing is 26x. And negative 24 take away nothing is negative 24. All right, how do I turn an x into a negative 7x squared? I need to multiply by negative 7, and I need another x. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. I subtract to see what's left over. Negative 7x squared take away negative 7x squared is 0. 26x take away 14x is 12x. Negative 24 take away nothing, it's negative 24. All right, last step, how do I turn a x into a 12x? I need to multiply by 12. 12 times x is 12x. 12 times negative 2 is negative 24. 12x take away 12x is 0. And then negative 24 take away negative 24 is also 0. And that is how I know I did this right, because the remainder is supposed to be a 0. That was how I came up with the 2 in the first place. So I always feel good to know that that actually worked out. That means that my expression x cubed minus 9x squared plus 26x minus 24 is the same thing as x minus 2 times x squared minus 7x plus 12, and then plus the remainder of 0, but I don't really need to put the 0. Now I need to see if I can factor that any further. I don't have a lot of space, so I'm just going to keep working here because that's the only room I have. It has 3 terms. They do not have a common factor, but it is the trinomial shortcut, meaning if I can find the numbers that make this work, then I can just write it in one step. I don't have to use decomposition. So I'm looking at things that multiply to 12 and add to -7. By the way, it is the shortcut because there's just a 1 in front of the x squared. All right, things that make 12, 1 and 12. That would give me 13 if I add and 11 if I subtract. 2 and 6, they would add to 8 and subtract to 4. 3 and 4 would add to 7 or subtract to 1. So I am going to do 3 and 4, but in order to get a -7, it would have to be -3 and -4. So I can use the shortcut here. So this is going to be x minus 2. And then the shortcut says that instead of using decomposition, this is just going to be x minus 3 and then x minus 4. We just use the 2 numbers that we found. And that only works when there's nothing in front of the x squared. Okay, now that I have factored this, it is going back into that log equation that we started with. So I'm going to replace the numerator with x minus 2, x minus 3, and x minus 4. Now, denominator. I'm hoping I don't need to do it off at the side because I am pretty much out of room. X squared take away 4x. I do have 2 terms, and I notice they have a common factor. They both have an x, so I can common factor out the x, and then x squared divided by x is x, -4x divided by x is -4. All right, from here, I do see that there is an x minus 4 on the top and an x minus 4 on the bottom. So I'm going to split it up. You don't have to do this step, but it's our note, so I'm trying. So x minus 2 times x minus 3, and then times x minus 4. And then this is going to be x times x minus 4, right? The x minus 4 times x minus 4 is just 1. Right, those are going to divide to give me a 1. And then anything times 1 is itself. So I'm just going to get log base 6 of x minus 2, x minus 3, and then divided by x. And that is going to be my final reduced answer. Now, as I mentioned, you do not need to put that middle step in. If you feel confident that you can reduce from here to here and do it correctly, then do that. If you want to show that extra step, you're also welcome to do that. Okay, you've got the rest of the period to work on your reducing expressions practice.